Alright, in the last lecture we learned how to use functions in Mathematica. Today we are going to learn how to use plot. So let's start with a very simple example. Let's say plot. And as I mentioned earlier, when we use functions in Mathematica, we start with the capital letters. So here we start with P, capital P, and then we use square bracket, and then we just input the function that we would like to plot. Let's say in this case we are interested in cosine function, cosine x, and then I'm going to use squiggle parentheses here. So this, let's say x goes from minus pi to positive pi, and I close the parentheses, I close the square bracket, and then press shift enter, and as you can see the plot appeared here. So this is first function. So if I'm interested in showing multiple functions in a single graph, I can do following. Right after the square bracket, I introduce a squiggly parenthesis here. So I type two functions here. Let's say sine x square. Let's say this is the second function that I'm interested in, sine x square over x. So, and then I need to close the squiggly parentheses, and this is the comma range for both of them, and then I press shift enter or right enter. So this is the function. So again, the blue one is the first one, cosine x, and sine square x over x is the second one. So again, sometimes this may be misleading, so you may be confused which is which function. So it is possible to show the legends here. So we can do that as follows. We have cosine x, sine square x. Then I have to select an option to show the legends. So to do that, I just plot. I type plot legends, and as you can see, as you are typing it, it appears here. I just click on it, and then after the arrow sign, I will select, I will type the following, expressions. So it is going to show the expressions that we use to plot the functions in this case. So if I type it again, so you can see the blue line is cosine x, and the orange line is sine square x over x. So this is how we show the expressions, how we show the legends in the function. Okay, let's do a little more here. So let's say I'm interested in plotting a function on a domain. Let's say I have a function which is only defined in a specific domain. How do I do that? How do I plot this in Mathematica? For this purpose, we need to use region function. Let's see how we do that. Let's say if I just plot sine x, sine x, let's say from 0, x goes from 0 to 6 pi. This is how it looks like. This is as expected, nothing interesting. But if I want to I would like to restrict the sine x function in a certain domain. So I will do this as follows. So I say region function. So it appears already here. I just click on it. And then I need to specify what is the domain, what is the region that I would like to plot the sine x. So let's say function square bracket x, y, absolute value y greater than 1 over 2. So right now, so for the absolute, we are going to plot this function, sine x function, for all the x values when the absolute value of y is greater than 1/2. In other words, so we are cutting the region where the absolute value is less than 1/2. All right. So if we are interested in doing the opposite, so if you are interested in showing the region in between them, so we just change the sign here. So we can say absolute value less than 1/2. In this case, we are going to cut it off from the top. Again, this is one way to do it. So in this case, I define the function. This function is a function of x and y. And this is how we restrict a function on a certain domain. So what happens if we have a function that changes very rapidly in y value? So if this is the case, you know that we would like to use log plots to show variation in the data. So for instance, if you plot x to the x to the x power, and I would like to plot another thing next to it, let's say absolute value sine x factorial. Alright, this is a complicated function, but let's say we would like to plot this. And let's say we are interested in plotting this function from 1 to 5. Alright, and also for our for visualization purpose, let's also illustrate the legends so that we know which is which. Expressions, this is going to show us the legend. So let's close the parentheses, square bracket, and then press right enter. Okay, so here what happens? So we have two functions. We see one of them, x to the x, increases very rapidly. On the other hand, the other function is basically almost looks like constant. So if you like to see the variation in both functions, then we should use something else. We should use log plot. When we use log plot, we will basically change the y-axis in logarithmic scale. So if I plot log, so you can see here, you see the variation very clearly. So in log plot, x to the x is almost looks like a linear line, and this is sine x factorial. Alright. So analogously, if you have very large variation in x value, on the other hand, when you don't have a big variation in y value, then you would like to plot log linear. So for instance, if you are interested, let's just plot hyperbolic tanh x, and in here x goes from 0.1 to 100. Alright, and you see it looks like 0, it looks like 0 everywhere. It looks like, sorry, 1 everywhere. So it appears that there is no change. However, if we zoom into this function, especially in this region, below 20 region, let's say log linear. So in this case, we are going to make x-axis log scale. All right, okay, L should be capitalized, of course. So I'm going to press right enter, and you can see here we are zooming in in this region. As you can see, the most of the change is happening between 0.1 to 1. So if we are interested, we can even zoom in further. We can say plot it from 1 to 100, and you can see there is a drastic change below below 3.5 or so. And if because of that, this function is more convenient to use. All right, and if, of course, if you have a large variation in both x and y, then you would like to use log plot. So for instance, if you are interested in plot, let's say plot multiple functions here, x squared, x cubed, x to the 4, x to the 5. We are interested plot in seeing these functions together. Let's say for the range of x goes from 1 to 1000, and I would like to also see the plot legends, and I would like to have expressions here, and then I close the bracket, and you can see here we have all the functions. As you can see, they are overlapping, so like especially so I could only see these two functions. Blue and orange ones are overlapping. So, and also we are covering very large range. So because of that, this is a very good example to use log plot. So I just, instead of using just plot, I use log plot and press enter. And you can see here, you can clearly distinguish these functions, and in both x and y. So this is a good example for log plot. Alright, so let's say this is the first breakpoint. So why don't you try to use these functions your own? Okay, so if you are following this from YouTube or from another video source, just pause your video and just practice these using Mathematica.